Lesson 7B, we're going to do confidence intervals for the mean when we have a small sample. All right, so last lesson 9A, we did confidence intervals for the mean and we used z-scores. So we used that z sub c to find our margin of error. That only works if the sample size is greater than or equal to 30 or we know the population standard deviation. So you have to have one or both of those things to use z-scores. All right, but sometimes that's not always possible. We very rarely know the population standard deviation. All right, and sometimes we can't always get a sample size of at least 30. So when those things happen, we use something called a t-distribution. All right, and so this is a comparison. You can see all the different colors. This green one right here is the normal distribution, the one that we've been working with z-scores. And then you can see the different t distributions. So the t distribution is based on something called degrees of freedom. And we get that from the sample size. So degrees of freedom is n minus 1. It's always our sample size minus 1. Okay, so both our z-score, our normal distribution, and our t-distribution show the probability of something happening based on how far away it is from the mean. All right, and the way the t-distribution works is as the degrees of freedom gets closer and closer to 30, the t-distribution gets closer and closer to the normal distribution. Okay, so that's why once it gets to 30, we just use z-scores, we just use the normal distribution because then it's the same. All right, so steps for confidence intervals, still the same thing, just a little bit, just small changes in the formula. So sample statistics, X bar, we still need our point estimate for the mean. We're still going to use S for standard deviation unless the population one is given to us. Identify the degrees of freedom. So we already talked about that. Degrees of freedom is just N minus 1, so sample size minus 1. Level of confidence. Again, most common 90, 95, 99, going to be given to you in the problem. Okay, the critical value TC, that's going to come from the T table. So I'm going to give you guys a T table, all right? And when we did z-scores, I gave you the z-scores for 95, 90, 95, and 99. But we're going to have to use the T table here because it's different based on what degrees of freedom are. So we'll look at how to use the T table. Okay, margin of error, almost the same. Instead of Z sub C, we have T sub C because we're using the value from the T table, and then it's still standard deviation over the square root of the sample size, N. All right, and then last step is still the same. We're going to add and subtract our margin of error to get our confidence interval. All right, so here's our example from a random sample of 20 cars. Okay, the mean number of days the car sat in the lot before it was sold was 9.75, and we had a standard deviation of 2.39 days. Construct a 99% confidence interval for the mean number of days a car sits on the lot before being sold. Okay, so our sample statistics, X bar, they gave it to us. It was 9.75 for our 20 car sample. And then the standard deviation was 2.39. All right, so always nice when they give it to you. If they don't and just give you a list of data, then we would use our 1var statistics just like we did in 9A. All right, identify the degrees of freedom. Degrees of freedom, remember, is n minus 1. So we had a random sample of 20 cars. Minus 1 would give me 19. All right, level of confidence, they want a 99% confidence interval. Okay, so now find the critical value. Remember, that's T sub C, and that's going to come from the T table. Okay, so this is what the T table looks like. We have degrees of freedom on the left and then confidence level on the right. And so we just go to where the row and confidence level that we want overlap. So we had 19 degrees of freedom because we had a sample size of 20, and I want a 99% confidence level, so I'm just going to go across 19 until I get to 99, and so it's right there, 2.861. That's the number I want for my T sub C. Okay. Okay, so my T sub C is going to be 2.861, and that number just came from the T table. So now margin of error, all right, is T sub C, so 2.861, times standard deviation, 2.39, over square root of the sample size, which was 20, and then we do that math. All right, and I'm going to round this to the nearest hundredth, so I got 1.53 as my margin of error. So then to construct my confidence interval, I'm going to take my mean of 9.75, I'm going to subtract the margin of error, and then I'm also going to add the margin of error. All right, 9.75 minus 1.53 is 8.22. Added together, it's 11.28. Okay, so this is my confidence interval. All right, and remember the interpretation of that is I am 99% sure that the mean number of days a car sits on the lot is somewhere between 8.22 and 11.28. All right, so now we've done two different distributions. So in 9A, we did the normal distribution, the z-scores. And in 9B, now we've done the t distribution, okay? And we use that t sub c. So how do you know which one to use? All right, this little flow chart sort of gives you the answer to that. So if n is greater than 30, all right, greater than or equal to 30, we can use the normal distribution. All right. If n is less than 30, but we know the population standard deviation. So that's something that's going to be important for you guys to know. The sigma is population standard deviation. The S is sample standard deviation. Okay, so that's going to be important. So if n is less than 30, but I know the population standard deviation, I can still use the normal distribution. All right, if neither of these things are true, n is less than 30 and I don't know the population standard deviation, then I'm going to use a t distribution. Okay, so you need to pay attention to the information that is given to you in the problem so that you know which distribution to use. Okay, so let's look at an example. You have a random sample of 25 newly constructed houses. All right, then they give us the sample mean, x bar, and the population standard deviation, sigma. Assuming construction costs are normally distributed, should you use a normal distribution, t distribution, or neither? All right, well, n is 25, all right? That is less than 30. So then I have to look at which standard deviation they gave me. They gave me population standard deviation, so that means I'm going to use the normal distribution. So I would use z-scores. All right. So you got to go through that flow chart. If n is greater than or equal to 30, normal. If you have population standard deviation, normal. All right. If not, t distribution. Okay. And that is it for 9B.